So we studied about all this. So what are the formulas we have studied now until now? V is equal to I into R. Then R is equal to rho into L by A. Then what else we studied? What is work? We studied
Q by T.
Q by T. What is Q by T? Current. Current is equal to Q by T. What is Q? N into E also you can consider. N into E by T. What about the relation between work, voltage? You have work, right? Work, voltage, all these sequence. What we have said.
Ma'am,
Huh.
V is equal to W by Q.
Huh. Repeat again.
V is equal to W by Q.
V is equal to W by Q. That is voltage is equal to total work done per unit charge. Okay. So that was the formula we studied. Okay. Now, we will see about the series resistance, parallel resistance and all. Before that, I'll just write the circuit, how any circuit looks like. For example, you have one resistor. You have a voltage connected to some battery here. Then you will have some key. Then you will have an ammeter. To measure here voltage, think we will have an voltmeter, something like this. So this is a battery which will give you the potential difference required. Because of that only current will flow. So this is the positive terminal, negative terminal, positive terminal, negative terminal. This is plus and this is minus. This is key. Key means it is a switch to on and off. Okay. And this is a resistor. So between the 2 points, see, potential difference is considered between the 2 points. So if you want to measure the potential difference, so you have to from between which 2 points you need the potential difference. There you will connect the voltmeter. Voltmeter is a device used to measure voltage. Okay, and this is a voltmeter. And ammeter. Ammeter is a current, is a instrument used to measure the current. Okay, so ammeter, see, how current will flow. I told that current we consider from positive terminal to the negative terminal. So current will flow like this and it comes back. And one thing, it should be always a closed path. It should be always a closed path to current to flow through it. Okay, switch actually does the same thing. When switch is on, it will be a closed path. When switch is off, it will not be a closed path. Okay. So current will flow like this. Current will flow like this. Ammeter is the one which is connected to measure the current. And always remember, for voltmeter and ammeter also there is a polarity. Okay, and always you have to connect such a way that positive terminal of the should be connected to the positive terminal of the voltmeter, and negative terminal of the voltmeter should indirectly or directly connected to negative terminal. Even ammeter like this. This is, see, this is negative terminal, no? So this is minus. So negative terminal of ammeter has to be connected to negative terminal. Positive terminal of the battery should be connected to positive terminal like this. So this is the circuit diagram, how it looks, how resistor is connected to ammeter, switch, battery, something like that. So if there is another bulb also here, just write the circuit diagram. So you will know, just write as a note and know, so that you will know, get used to these things. And you will have, think, another one, you have a bulb. So resistor, this is a bulb, battery, key, ammeter, and I want to measure the voltage this time across the bulb. So I will keep the voltmeter here. And here also positive terminal of the battery to positive terminal of the voltmeter, negative terminal to the negative. So you can write like bulb connected in the circuit, electric circuit, bulb connected in an electric circuit. Here resistor, you can write resistor connected in an electric circuit. In an electric circuit. So how it looks like. Okay. Now resistance of a system of resistors. Write down first, then I will explain. Okay. Resistance of a system of resistors. First one, resistors in series. Resistors in series. Okay. When two or more resistors are connected end to end to each other, then they are said to be connected in series. Then they are said to be connected in series. Okay. Write down this. There are three resistors, R1, R2, R3 here. And this is one key. Then you have a battery. This is ammeter. Positive, negative key. This is positive, this is negative. Okay. And voltmeter, we will connect across all the three. So there are three resistors here. The way they have connected, we call it as resistors are connected in series. Okay. How they are connected, we call that resistors are connected in series. The mark points also required. Is it done? Listen here. See, resistors R1 and R2 and R3 are there. They are connected in series. How we will say they are connected in series? If you observe, one end of the R1 is connected to key. Okay. The other end, it is connected to R2. So R1 and R2, their ends, one end only is connected between them. And R2, the other end, it is connected to R3. So R2 and R3 are connected in one end. R1 and R2 are connected in the other end. That means only one end is connected to each other here. Okay. And R3 is connected to the ammeter to the battery. Here, only one end is connected, not both the ends are connected. So at that thing, we call it as series. So then we call it as series. Okay. So kids, they will play, right? When they are playing, they will keep one hand with the one friend, the other hand with the other friend, right? Like that. So only one end is connected to the next resistor, but the other end is connected to somewhere else, right? So only the one end is connected, then it is called as series. In the series, if you observe, current through all the resistor is same because there is only one path to flow. See here, this is the voltage. I have some voltage V I have applied here. Okay. So current starts switch. I have closed the switch so that current will flow through here. Here it flows like this. And now the total current, whatever current is there, it flows through all this resistor and it's the same thing here. And then it comes back. This is a closed path like this. Because there is no other path for the current to flow here. So whatever current is there, it will flow through all the resistors and same value of the current will flow through all the resistors here. Correct? Same current will flow through all the resistors. So in a series connection, always the same current flows through all the resistors. Okay. Now what about the voltage across the R1? What is the voltage at the R1? If I take R1 ends as A and B. Correct? There is some voltage here. We will measure if you measure. So this we will call it as V1. Okay. So R2 is between the other 2 points here. Correct? So here there will be some voltage. So this will be called, we can call it as V2. And R3, it will have the voltage between this C point and D point. This we call it as V3. Because they are between different points, the voltage across them are different. They have different voltages. But current through all the resistors is the same because there is only one path, like water flows. If there is only one path is there for the water, all the water will flow in that path only. Correct? And if there are some plants in that path, all the plants will get the same water because there is only one path. So here also in the series connection, what happens? Same current will flow through all the resistors because there is only one common path for all. Okay. But voltage across each resistor will differ here. Why it will differ? Because see, the R1 is between A and B and R2 is between B and C and R3 is between C and D. So at different points you will have different voltages. So across R1 voltage is V1, across R2 voltage is V2, and across R3 voltage is V3. Okay. Now we will try to see what will be if I remove all the three resistors and I will put one resistor, equivalent resistor, then also I should get the same current through this. See, I will remove all the three. Instead of that, I will put some RS, series equivalent resistor, such a way that for the same voltage V, keep ammeter also here. Okay, I should get the same current I. I will replace all the three and I will try to put one equivalent resistor such a way that I should get the same current I for the same voltage V. So what is that equivalent resistance? That we will try to calculate. Understood? So first thing, series means only one end will be connected. Then we call it as series. Okay. Then in a series circuit, what happens? The current through all the resistors will be the same because it has only one path. All current will flow there only. Okay. But voltage across R1, R2, R3 will be different because they are at different points. Correct? So here you have different points here. So that is why voltage across R1 we call it as V1. This is V2, V3. Okay. But all the three together should be equal to this V voltage. Why? Because this is the voltage you are providing. Correct? No? So, see, for example, how much you will eat, that much energy you will have. Correct, right? So that is like that. How much you read, that much you can write. Like that only. Whatever voltage we are applying, it is only through battery. That is total V. So whatever voltage across R1, R2, R3 will be equal to V total voltage V. Like that. Understood this much? Write down done. This is done. Total voltage. Wait. A few things will write in between. Sometimes they ask this derivation also. Write down. An applied voltage. An applied voltage V. Okay. Produces current I in the resistors, R1, R2 and R3, causing a potential drop. Potential drop also same thing, voltage only. Okay, potential drop V1, V2 and V3 respectively. Then total potential V is equal to V1 plus V2 plus V3. Okay. Next, by Ohm's law. Ohm's law. V1 is equal to I into R1. V2 is equal to I into R2. V3 is equal to I into R. Thus, V is equal to I into R1 plus I into R2 plus I into R3. V is equal to I into R1 plus R2 plus R3. Okay, so for the series circuit, so what we are trying to write is, so we have applied some voltage V here. For that, we are getting that current I. Okay, and that same current will flow through all the three resistors. So produces current in the resistors R1, R2, R3. Okay, and this causes some potential drop across each points, across each resistors, which we call it as V1, V2, V3. And whatever voltage we have applied, that only will be there here, right? It can't be more than that. So by law of conservation of energy, so total voltage V will be equal to the voltage across R1 plus R2 plus R3. That is V1 plus V2 plus V3. Now we will try to apply Ohm's law. Ohm's law, what we studied, V is equal to I into R. Correct? So we will apply Ohm's law for the first resistor. What happens? The resistance is R1 and the current flowing through this is I. Correct? So, and whatever we measure voltage, that is equal to V1 here. So V1 is equal to I into R. So current through this is I, this is the resistor value, and whatever voltage we measure here is V1. So V1 is equal to I into R1. What about V2 here? I into R2. What is V3 here? I into R. Okay, so all the three voltages are this. So now total voltage V should be equal to this I1 into R1 because that is equal to V1 plus I into R2 plus I into R3. I is same for all. I can take it common. So V is equal to I into R1 plus R2 plus R3. Okay. Now, what I'm trying to calculate here is, if I remove all the three and if I put one resistor, now also I should get, for the same voltage, I should get same current. So that resistance value, I will call it as equivalent resistance for series. Okay. So instead of all the three, I will remove all the three. I will put some resistance value RS here. Okay. So still I will apply the same voltage here. Okay. And I should get the same current I. So here what same for RS, I can write it as, what is the current flowing through it? I. Voltage applied is total V. So RS is equal to I into V. Correct? Huh? So now if you observe, what will be RS equal to? So sorry, not RS. V is equal to I into RS. So total voltage V will be equal to, because everything is applied across RS only, so I into RS. So this you will call it as equation 1, equation 2. Both are telling about the V, total voltage V only. So I can write it as I into RS will be equal to I into R1 plus R2 plus R3. Okay. So R equivalent for series is equal to R1 plus R2 plus R. Okay. That means if I want to replace all the three series resistor by one resistor, I have to add all the values of resistance, put that value here. I will get the equivalent resistance. Okay. The current through each resistor is same. Okay. The potential difference, okay, potential difference across each resistor is different. See, potential difference, okay, or potential or voltage, everything it indicates the same thing, same meaning. Potential difference, potential, voltage, everything. So in a series circuit, current through each resistor is same, but potential difference between each resistor will be different. That is a key point you have to remember in this series circuit. Okay. Done. Hmm. Hmm. Everyone there, Vihan? Next, we'll see another type of circuit, resistance in parallel. Write down. Second one, resistors in parallel. So what is resistor? Resistor is a component which provides the resistance. Okay, resistor is a component which provides the resistance in the circuit. So resistors in parallel. In parallel. When two or, write down this, when two or more resistors are connected simultaneously. They are connected simultaneously between the 2 points, between 2 points to each other, then they are they are said to be connected in parallel combination. Connected in parallel combination. Write down this then. An applied potential difference inside. Okay. Okay. I1 in R1, I2 in R2, and I3 in R3. Okay. Now, resistors in parallel. Parallel means any resistors, if they are connected between the same 2 points, we call it as parallel. Okay. So if I call this point as A, okay, and this point as B. See, all R1 is connected between point A and B. R2 is connected between A and B, and R3 is also connected between A and B. Okay. So, if the resistors are connected between the same 2 points, then we call it as parallel. Okay. Oh, okay, fine. No problem. That insect is different. Yeah. Okay. So resistors in parallel means they listen this carefully. So when they are connected between the same 2 points, then we call it as a parallel. Okay. Then we call it in parallel. See here, R1, R2, R3, all the three, one end is connected to point A, the other end is connected to B. That means what? R1 is connected between A and B. R2 is connected between A and B, and R3 is also connected between A and B. That means all the three are connected between the same 2 points. Then we call it as parallel. Okay. If you observe, this is the voltage I have applied here. Now the current through this will be total current I. Now the current has three paths here. Correct? There are three paths to flow. So some current will flow through this. This is I1. Some current will flow through this I2, and some current will flow through this. This is I3. So whatever total current will be produced due to this voltage, it is divided between all the three resistors. Because there are three paths, it can water also, right? If it has three paths, then some water will flow in one path, second some water, third one. It depends on the different thing. Oh God. Current, see the voltage V, what we are applying here will produce some current I. Okay, so that is divided between the three parts. Because it has three parts, it can divide. Correct. So it is divided as I1, I2, I3. So I1 is the current that is flowing through R1. I2 is the current that is flowing through R2, and I3 is the current that is flowing through R3. Okay, all the three together it will combine. Here the total current will flow through like this. Okay, here current is divided between the resistors. Current is divided between the resistors. And how it is divided? See here, total current, whatever is there, that can be only divided by all the three, right? So total current I is equal to I1 plus I2 plus I3. And since they are connected between the same 2 points, they have the same voltage. Okay, since they are connected between the same points, so they have to have the same voltage. So all the three resistors will have the same voltage, but they will have different current. Okay. Now here, since there is no voltage drop somewhere else, so whatever voltage I have applied here, complete thing will be across all the three. Okay. Again, I repeat, see, current, since there are three parts, it will divide. So it will be like I1, I2, R3, I3. And the total current I will be equal to sum of all the three currents. So I1 plus I2 plus I3. And since they are between the same 2 points, the voltage is measured between any 2 points. So the voltage across all the three will be the same. Here in this circuit, there is no other voltage drop. So whatever voltage we are applying here, so complete voltage will be here. Okay. Understood, right? Now we will try to apply Ohm's law for each resistor and try to find the equivalent resistance. Write down, this is done, everyone. Hmm. So we have I is equal to I1 plus I2 plus I3. Okay. So by applying Ohm's law, okay. So I1 will be equal to what? V by R1. So here, what is I1 equal to? The see, we know V is equal to I into R. I will be V by R, correct? Voltage by resistance. Now here, if I consider I1, what will be I1? Okay, what will be I1? I1 is equal to voltage across R1 is V by the resistor R1. Then I2 will be equal to the voltage across R2 is also same V by R2. And I3 will be equal to voltage across R3 also same V by current by resistance R3. Okay. Now we will try to substitute I1, I2, I3 in this first equation. So what you will get? I is equal to V by R1 plus V by R2. Okay. Plus V by R3. Okay. So I is equal to V common if I take. V is a common here. 1 by R1 plus 1 by R2 plus 1 by R. Okay. Now, instead of all the three, I will put one resistor. I will call it as RP. Okay. So, for the same voltage, I need the same current I. So, I will remove all the three. I will put one equivalent resistance RP. And for that also, if I apply same voltage V, I need the same current. Here I. Okay. I need the same current I. So, now for this circuit, if I apply Ohm's law, what I will get for same current I for the same voltage by R. So this I'll call it as 2, equation 2 and this 3. Both 2 and 3 LHS is same. If I equate, what I will get? And now we have to calculate. Okay.
Okay, it's the third.
See, I will remove all the three. I will put one resistance. But still, I need for this same voltage, I need the same current. So I've removed all the three. I've put RP here. I've put the voltage same V and I'm getting same current I. So now I will apply Ohm's law. What is Ohm's law? If current I is flowing through that is equal to whatever voltage you have applied. That is V divided by its resistance. That is R. Okay, so these two are the same current I. Now I can equate that. It is done, everyone. Here we will end the today's class. Do not forget to subscribe the channel. If the content of this channel is useful, please like the video and share with your friends. Thank you.